Introduction to Data Science. This course provides comprehensive introduction to data science, covering fundamental concepts, tools, and techniques. You will explore how data is collected, processed, analyzed, and visualized to make data-driven decisions. Whether you're new to data science or looking to strengthen your foundation knowledge, this course will help equip you with essential skill for working with data. By the end of this course, you will have a clear understanding of data science workflows, machine learning basics, and how data-driven insights drive decision making in various industries. Course objectives. By the end of this course, participants will be able to define data science and understand its role in modern industries, explain key data science concepts, including data wrangling, exploratory data analysis (EDA), and machine learning. Identify common tools and programming languages used in data science, Python, R, and SQL. Understand data collection, cleaning, and pre-processing techniques. Perform basic exploratory data analysis using pandas and matplotlib. Explain the fundamentals of machine learning and its real-world applications. Recognize key career paths and job opportunities in data science. The target audience. This course is ideal for beginners interested in starting a career in data science, students or professionals transitioning into data-driven role, business professionals looking to leverage data for decision making, tech enthusiasts curious about AI, machine learning, and analytics. Below are the modules of this course.
Would one of this data science course, where we'll be looking into the introduction to data science on the following units. What is data science? The data science lifecycle and the real-world application of data science. Overview of data science. What is data science? At its core, data science is the study of data to extract meaningful insight, often for business purposes. It represents the practice of understanding data and leveraging it to address real world problems. In an era where organizations are inundated with data from many sources like sensors, machines, online interactions, and more, data science provides the tools, methods, and technology necessary to transform this raw data into actionable knowledge. Simply having data is not enough. Data science is the discipline that converts these raw numbers and observations into valuable informations. Characteristics of data science. A key characteristics of data science is its interdisciplinary nature. It is not confined to a single domain, but rather emerges from the convergence of several fields. Secondly, data science majorly blends computer science, encompassing programming skills, algorithms, and data management techniques. Statistics, providing methods for analyzing data, testing hypotheses, and understanding uncertainty, and domain expertise, the specific knowledge related to the industry or area where the data originates, such as healthcare, finance, or retail. This unique combination allows data scientists to clean, combine, analyze, and interpret vast and complex data set to solve intricate problems. Recognizing this blend is important for newcomers as it signifies the proficiency in data science involves developing a breadth of knowledge across these areas rather than just deep expertise in one. Thirdly, it also undergoes the collaborative nature of many data science projects where individuals with different strengths work together. Fourthly, ultimately, the practice of data science aims to answer fundamental questions that drive decision making. This question often falls into categories like descriptive analysis, which entails what happened, diagnostics analysis, which entails why it happened, predictive analysis, which entails what will happen, and diagnostics analysis, which entails why did it happen. Then predictive analysis, which entails what will happen, and prescriptive analysis, which entails what should we do about it. By addressing these questions, data science provides the foundation for evidence-based strategies and action. The data science life cycle. Overview of the data science life cycle. Data science projects, while diverse, typically follow a structured process or workflow, often referred to as the data science lifecycle. This lifecycle provides a framework for organizing and managing the steps involved in extracting insights from data. It's important to understand that this process is rarely a rigid, linear sequence. Instead, it's often an interactive cycle where insight gained from one phase might necessitate revisiting earlier steps. Having a defined workflow, however, acts as a valuable set of guidelines, helping teams plan, organize, and implement their project effectively. Frameworks that describes data science lifecycle. Several frameworks exist to describe this lifecycle. Two widely recognized models are CRISP-DM, that is cross-industry standard process for mining data, and OSEMA, which is obtain, scrub, explore, model, and interpret. While differing slightly in their specific phases, they share common underlying principles and provide a structured approach to data science tasks. Synthesizing these frameworks reveals a set of common key stages present in most data science projects, which are number one, understanding the goal or problem, which is the business understanding. This initial and critical phase involves defining the project's objectives and requirements from a business or research perspective. It requires understanding what the stakeholder aims to achieve and defining clear success criteria. This steps drives the entire process, ensuring the analysis remains focused and relevant. Secondly, getting the data or data collection. This stage focuses on identifying, acquiring, and accessing the necessary data from various sources, such as databases, files, APIs, or web scraping. The quality and relevance of the data collected here are foundational for the project success. Thirdly, preparing the data or data preparation. Raw data is rarely ready for analysis. This stage involves cleaning the data, which involves handling errors, missing values, and duplicates, transforming it into suitable format, and potentially integrating data from multiple sources. This is often cited as one of the most time-consuming phases in data science projects. Fourthly, explore the data or data exploratory analysis. Before formal modeling, data scientists explore the data to understand its structure, identify patterns, detect anomalies, and generate initial hypotheses. This involves statistical summaries and data visualization techniques. Modeling. Modeling is where algorithms, often from machine learning, are applied to the prepared data. The goal is to build models that can predict the future outcomes, classify data, or uncover deeper patterns based on the project objectives. This involves selecting an appropriate techniques and training the models. Sixth, evaluating. Once models are built, they must be evaluated to assess their performance. and determine how well they meet the initially defined business objectives. These steps help to choose the best model among alternatives and ensure the results are reliable. Number seven, deploying or interpreting. The final stage involves putting the model into production for practical use, or more broadly, communicating the findings and insights derived from the analysis to stakeholders. This could range from generating reports and visualization to integrating a machine learning model into an application. This iterative nature mentioned earlier is crucial. For example, insight from the exploration phase might lead back to collecting more data, or poor results in the evaluation phase might require visiting or revisiting the data preparation or modeling stages. Success hinges not just on technical execution, but on clear understanding of the initial problem and adapting the process as understanding evolves. Real world applications. The impact of data science is widespread, touching nearly every industry and aspect of modern life. Its application demonstrates the power of transforming data into actionable insight and automated decisions. Examples of diverse applications of data science. Here are a few examples that are concise, illustrating its diverse utility. E-commerce and entertainment personalization. Many online platforms leverage data science to enhance user experience. Recommendation system like those used by Netflix to suggest movies or Amazon to recommend products. Analyze past user behavior, viewing history, purchase history, browsing pattern to predict future preferences. These system employs algorithms to identify patterns and deliver personalized contents, driving engagement and sales. Healthcare advancement. Data science contributes significantly to healthcare, from improving diagnostics to predicting patient outcomes. For instance, Google Lima lymph node assistance 2 utilizes machine learning to help pathologists identify metastatic breast cancer cell in lymph node biopsies, potentially increasing accuracy and speed of diagnosis. Predictive models can analyze patient data to forecast disease risk or treatment effectiveness. Transport and logistics optimization. Companies involved in moving goods or people use data science to improve efficiency and reliability. UPS, for example, employs its Orion system, which uses advanced algorithms and machine learning optimize delivery routes for drivers, saving millions of miles and gallons of fuel annually. Airline also use data science to predict flight delays, optimize routes, and manage pricing strategies. Financial fraud detection. In the finance sector, data science play a crucial role in identifying and preventing fraudulent activities. Machine learning algorithms analyze vast amounts of data transaction in real time to detect unusual patterns and anomalies that may indicate fraud, helping protect both financial institutions and consumers. These examples highlight how data science translates data patterns into tangible benefits, ranging from personalized experiences and operational efficiencies to improve health outcomes and enhance security. It is not merely an academic pursuit, but a practical discipline driving innovation and decision making across the field. All right. To perform data manipulation, data cleaning, data analysis, data scientists rely on various software tools in the Python ecosystem. A few libraries are foundational and widely used, particularly for handling structured data. So first thing we're going to be doing is the download of Anaconda. Now, Anaconda is an open source of distribution of Python and R products. So within Anaconda is our Jupyter notebooks as well as a lot of other things. We're going to be using for Jupyter notebooks. So let's come right down here, right? First thing download. So you can download from here. If you download this graphical installer. All right, so you can actually select under the distribution installer check you're using Windows, Mac, or Linux. I'm using Windows, so I'm going to be clicking here under the just 4-bit graphic installer. So you're going to click on it. Once you click on it, it's going to start download at 12024. So download gone. All right, so it's going to take about 2 to 3 minutes. Remember, you have to change the bit on your system to the system setting, the 64-bit to keep it. Your download should take you between 2 per minute. So we're done here. So you click on it. Okay, so once your download is done, like I said, click on this. Once you click on it, it's going to bring up the installer for you, which is right. So you're going to be clicking on next. So one click to install it. So install for, I think just needs, okay. It has the installation type, like the type of installation you would like to perform. You will Anaconda 3. If you just use it, just use it. If you have multiple users, you can select it. But we're going to be selecting, that's me. It's just one. So go next. Now it's going to show you where you're going to be installing it on your computer. Okay, so this is the actual file path. So it's going to take the power of 5.2 gig of space. So I have plenty of space. Make sure you have enough space before you install it. So what did you do? We can come over here, right? Next. Now we can do some advanced installation options. So we can add on the Anaconda 3 to my path environment variable. So we're using Python. We can have a default path with whatever your Python IDE or notebook that you're using. So because of the possibility of using a lot of visual codes, right? Anything we do, you might be careful with it so you don't mess things up. And then for this add an Anaconda 3 to my path, it says it's not recommended. See that? Not recommended. So messing with this path is kind of something you might want to do once you know more about Python. I don't really recommend you. I can't recommend you having the checks, right? You can register Anaconda 3 as my default Python 3.12. You can do this on one. I'm going to keep it right this way. So I have the exact same set it as you do. So let's go ahead and click install. And now it's installed this on your computer. So it's going to add completion. So we're going to head to the next thing to be done. So set it up in the package. All right. It's still installing. Almost 3 seconds left. So to get it all wrapped up with and move to the next aspect of this installation process. Now, once we complete it, you can click next again. If you want to, you can add the launch Anaconda navigator or the train. Or if you like to add it, you can launch them. But I don't, but click finish. So we're done. So let's go down and click for Anaconda. So we have Anaconda navigator. So we're going to click on that. All right, with login, like I'm doing the first time, checking about. So it might not be all of this, or see your system releasing the Omra update, but this will updates up to the latest, the latest update that they are out. So it's still loading. I'll do because of it's of my system. I installing it after fresh from the system, right? So we have it loading. But we have the details. Oh, that is one distribution of Python in R. But we're gonna be adding different option here. Some are familiar here, right? We have Visual Studio Code, Spider, and then we still have one more. We're supposed to have a Jupyter notebook. So we have the events right here. We have our Jupyter notebook. So let's go ahead and click on launch. So this was the pop up on your right now. You can take most of which I did go forwards. So we're going to be opening a new digital notebook where we're going to be learning a lot of future code writing and um, tutorials. So you can use these areas to save things, to create folders and organize things, all of that. So if you have notebook from previous projects, you can upload it from here. We're going to be checking. So we're going to be copying up a Python 3. So when you click on new and click on Python 3, it set out, it's going to bring it here. Where we're going to be having most of our work done, right? So there's a cell. So let's do something in the cell, right? And print is the famous hello world. Print hello world. So first it's shift. We're going to click on shift, enter. So you have your hello world. If you had that something else, you see that it had be too, it reflected, right? So we're running by clicking shift, enter. And that is where all of our code is going to go, right? These are code cells. Picking these are code cells, and we have it on start over here. We're going to get to that. One thing I want to show you is that you don't have to really write code here. You can also do something called Markdown, right? Markdown is its own kind of, you could say, language, but it's just a different way of writing, especially with notebook. So I'm going to do is to do is sound. Where's the a moment, please? Different way of writing like merchant. Hashtag. I'm gonna do hashtag. Whatever I do as first. Oh, right. Just like here, I'll do that. So, hello, this is actually very important. One investor that is actually what it is. Actually save a pics, right? If you want to please then tie to you. Sorry, long please. So you can save to here. If you want, you can type do also to look like X, X, Y, Z, you know, those. So we can go ahead right here. X, Y, Z, you know. So where is it? Imperatives. Over here you can see the X, Y, Z new changes to the book well. Background means it's currently running, right? So we can run in X, Y up here. And we don't want it to, we can turn it down right there. You know, we do work, we would run the code anymore, right? So we're going to run up a new cluster, right? So let's do that. Let's do it. That all. Oh, here, another book running, right? So, if I have a look to another book writing, you take care of a lot of this. You don't make her seem handy, sir. You can also delete cells. So on can have code here. And here have code there. So once you remove this, you can just do this. Right? You can get rid of this by just using the code. Select the path. You can also copy selected cells. So you can copy selected cells. You can come around here, the pitch selected cells. Right? Paste out a packet cell. You can also little bits to define locate what you want them to be, right? Different views offsets that you have here. Just do a lot of things. So earlier I hit shift enter, right? We here we're going to work on a code, right? So clicking shift enter, you can just click on run this cell and advance, right? If you're working multiple codes that is actually remote here and it's not working properly, you can stop that by doing interrupt right here. And if you're trying to do within this corner, if it's not working properly, it will stop, right? You can restart it and you can try fixing your code. If also it does but you're trying to restart your corner, Like this one, if you want to restart the kernel and rerun the entire notebook. After we talk about it, so click on it, go. We have our code, a markdown code. Right? Thank you. So the next thing is right up here. If you click on file, you can create a new notebook. You can create a new notebook. You can create the existing notebook kind of. Actually, you can do a lot of things we're talking about here. Things you want to do. Undo, redo, cut, copy, set, view. You can add a lot of features on the view you prefer, right? So I'm run. Now all that's set, right? And we can actually really enjoy, right? Oh, and now that we worked through all that, we now have the Anaconda and Jupyter notebooks installed on your computer. In other future videos, we're going to be writing all how I could be the codes, right? Thank you very much. See you in the next video.
For watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.